Welcome to the Deep Dive. I'm your host, and today we're diving into something that's, well, it's changing pretty much everything about how we interact with technology.
Hmm.
Large language models, or LLMs. You've probably encountered them maybe as those customer service bots that sound surprisingly human, or perhaps using tools that spark creative writing.
Yeah.
Their influence is just
It
undeniable.
really is. And it's amazing how quickly they've become woven into our digital lives, isn't it?
Totally. So today we're eager to, peel back the layers and really understand what makes them tick.
Exactly. And that's our mission for this deep dive, really, to cut through some of the hype, maybe some of the noise surrounding LLMs.
Yeah, there's a lot of noise.
There is. We want to give you, our listener, a clear, kind of comprehensive understanding of what these sophisticated algorithms actually are, how they work, and maybe most importantly, what sets the different ones apart.
Right.
The goal is for you to walk away from this feeling genuinely well-informed and are
hmm
ready to navigate this whole rapidly evolving landscape.
Rapidly evolving feels like the understatement of the year, doesn't it? I mean, it really kicked off in a huge way with ChatGPT launching back in late 2022.
Oh, definitely. That was the catalyst.
Yeah, it just ignited what everyone's calling the generative AI race. And then suddenly you had tech giants like Google jumping in with Gemini. Meta AI quickly followed. The competition just escalated like
It
crazy.
became a full-blown race, yeah.
So this deep dive is really tailor-made to help you, our listener, make sense of it all, to navigate this exciting, but sometimes, let's be honest, kind of complex landscape.
Absolutely.
Okay, so let's start right at the beginning, the absolute basics. When we hear LLM, what should we be thinking? What even are large language models, fundamentally?
Right. So at its core, an LLM is an artificial intelligence system, and it's specifically engineered to, well, understand, generate, and even manipulate human language.
Okay.
Think of them as, I don't know, maybe the ultimate language maestros. It's not just about spitting out words randomly.
Right, not just predictive text on steroids.
Not at all. It's about comprehending context, nuance, intent, all those subtle things that make language, well, human. That's what allows them to engage with language in ways that feel remarkably natural.
That sounds incredibly complex for a machine. Is the big difference between these and older AI just a scale? Or is there something fundamentally different in how they understand? What's the secret sauce there?
That's a really good question. So the core technology behind these modern LLMs, it relies on deep learning techniques, specifically a type of neural network called transformers.
Transformers, heard that word a lot.
Yeah, and for good reason. They really revolutionized the field back in 2017. See, older neural networks, they process text sequentially, kind of like reading a sentence word by word, one after the other.
Okay, linear.
Exactly. But transformers introduced something pretty groundbreaking called self-attention mechanisms.
Self-attention mechanisms. Okay, that sounds important. How does that work? Can you break that down a bit?
Sure. Imagine it like this. When a transformer looks at a sentence, this self-attention thing lets it weigh the importance of different words in that sentence, and it does it dynamically.
Dynamically, meaning?
Meaning, it's not fixed. It looks at the whole sentence and decides, okay, this word is really important for understanding that word over there, even if they're far apart.
Ah, okay.
It's like a super smart editor who's highlighting key phrases and instantly seeing how everything connects, how every word relates to every other word.
I see. So it's not just looking backwards, it's looking everywhere at once.
Pretty much. That capability is what allows them to process truly vast amounts of text efficiently and build these incredibly rich, nuanced understandings of language. That's what makes them so much more sophisticated than what came before.
Wow. Okay, so it's not just predicting the next word based on the last few. It's understanding the entire context, sentence, paragraph, maybe more, to make the best prediction. That really is a huge leap.
It is a fundamental shift.
So what's their main purpose then? I mean, beyond just chatting with us, which is cool, what are LLMs really used for out in the world?
Oh, their capabilities are incredibly diverse. And that's mainly because they're trained on these just colossal data sets. We're talking vast amounts of text covering almost every topic imaginable, different styles, different contexts, scraped from the internet mostly.
Okay.
And this massive training lets them do a whole range of tasks. For instance, text generation is a huge one.
Right.
They can create coherent, contextually relevant text based on a prompt you give them. Could be an article, a story, a marketing email, even maybe a script for a deep dive like this.
Huh. Maybe.
Yeah.
Maybe not quite yet. So they can be like a ghostwriter for almost anything.
Potentially, yeah. They also excel at text completion, predicting and finishing sentences or paragraphs. Think of your phone's autocomplete, but like on super steroids.
Gotcha.
And then there's translation, converting text between languages with honestly surprisingly high accuracy these days. That's a massive benefit for global communication.
Yeah, I've seen some of those real-time translation tools. They're pretty impressive now. What about understanding feelings or answering specific questions?
Absolutely. They can perform sentiment analysis.
Okay.
So, figuring out the emotional tone in text, is someone happy, sad, angry, neutral? Businesses love this for understanding customer feedback, for example.
Makes sense.
And of course, question answering, providing precise, hopefully accurate responses to user queries based on the information they've been trained on, or sometimes information they can look up.
So they're not just creative, they're informational too.
Definitely. All this makes them incredibly valuable tools for businesses automating customer service, for researchers sifting through mountains of data, for content creators needing inspiration or drafts. They're just really versatile.
Okay, let's unpack this a bit. The journey to get here, it wasn't like LLMs just appeared fully formed in 2022, right? This has been building for a while.
Oh, not at all. It's a fascinating story, actually. The journey really began with much simpler approaches to natural language processing, or NLP.
NLP, right.
In the early days, we relied heavily on rule-based systems and statistical models. Very basic stuff. They could analyze text, but they really struggled with context and nuance.
Ah.
Often led to very brittle, sometimes pretty funny output.
I remember some of those early chatbots. Trying to get them to understand anything slightly complex was an adventure. Really highlights how far we've come, doesn't it?
It absolutely does. Like you said, those early systems were like trying to have a conversation with a very rigid instruction manual.
Yeah.
The progress is staggering. It's like going from, I don't know, a telegraph to a smartphone in terms of language ability.
Good analogy.
Then in the late 2000s, we saw the emergence of neural networks in NLP. That was a significant turning point.
Okay.
These models allowed for more complex representations of language, definitely a step up. But they were still quite limited in their ability to scale up. They couldn't really handle the massive data sets needed to unlock truly deep language understanding.
So they were better, but not big enough yet. So building on those neural networks, what was the next big breakthrough, the one that really set the stage for today's LLMs?
Well, here's where it gets really interesting, as you say. In 2017, everything changed with the introduction of the transformer model.
Okay, 2017, Transformer.
Yeah, introduced by a team of researchers, mostly at Google. Vaswani et al. Is the famous paper. This architecture completely revolutionized NLP because it used those self-attention mechanisms we talked about.
Right, the dynamic weighting of words.
Exactly. Letting models weigh the importance of different words dynamically, regardless of their position in the sentence. This was the pivotal moment. It just paved the way for the truly large, incredibly capable models we have today.
So the Transformer was the key architectural innovation.
Yeah.
And then people started building bigger and bigger models using that foundation.
Precisely. That led directly to the rise of pre-trained models. A prime example everyone talks about is BERT.
BERT, right. Bidirectional encoder representations from transformers.
That's the one. BERT was a game changer because it could learn from vast amounts of unlabeled data. Essentially, it read huge chunks of the internet, learning grammar, facts, reasoning abilities, all before being fine-tuned for specific tasks like question answering or sentiment analysis.
So a guy had general education first.
Kind of, yeah. This dramatically improved performance across the board because the models already had this broad understanding of language before they started their specific job.
And now here we are in the current state, which feels like, well, a whirlwind of constant innovation.
It really does. Today, models like OpenAI's GPT series, Google's PaLM, and now Gemini, they really represent the pinnacle, for now, of LLM development. These aren't just large. They boast billions, sometimes even trillions, of parameters, trained on incredibly diverse, massive data sets. And this scale lets them generate remarkably human-like texts, perform complex reasoning. It just shows the astonishing progress made in just a few short years. It's still evolving so fast.
What an evolution. Okay, so now we have a really solid grasp on what LLMs are, the tech behind them, and kind of where they came from. Let's talk about the titans. Who are the major players actually building these powerhouses today? Let's take that tour of the LLM landscape.
Right, let's meet the heavy hitters, the titans of text generation, as you put it. Each has their own approach, their own strengths, their own philosophy almost. This is where you really start to see the differences emerge.
Okay, first up, probably the name most people think of first, OpenAI. They've definitely been a front runner, especially with their GPT series.
Absolutely. OpenAI really captured the public imagination. Their GPT-3, launched back in 2020, was just a behemoth for its time,
Mhm.
175 billion parameters.
Wow.
And it quickly became incredibly popular for, well, everything. Content creation, chatbots, coding help. Its ability to generate coherent, contextually relevant text was just miles ahead of most things at the time.
And then came GPT-4.
Then came GPT-4, which significantly boosted those capabilities. Better reasoning, better contextual understanding. And crucially, it introduced multimodal inputs.
Right, text and images.
Exactly. You can now interact with it using images as well as text, which opened up a whole new set of possibilities. So OpenAI, yeah, they're clearly pushing the frontier on raw capability and making interaction feel very natural.
And they just keep pushing, don't they? I keep hearing about GPT-4o and this new O1 family. What's the big deal with those?
They absolutely do keep pushing. So GPT-40, the O stands for Omni, is designed for really seamless human-computer interaction. It's got what they call omnidirectional capability,
Omnidirectional. Okay.
meaning it can process text, audio, image, even video inputs, and then generate outputs in those same formats. It's incredibly fast, especially with audio responding in milliseconds, almost like a real conversation.
Whoa.
And performance-wise, it matches their previous top model, GPT-4 Turbo, on English text and code, but it's much better with non-English languages. And it's significantly faster and cheaper to run.
That speed, especially for audio, sounds like a game changer for interaction.
It really is. And then, looking even further ahead, OpenAI introduced their O1 model family in September 2024. This seems to be a major leap in AI reasoning,
Reasoning. Okay. How so?
particularly for complex problem solving. Math, coding, science. The O1 preview model, for example, apparently performs at PhD-level proficiency in some subjects. They mentioned it scored 83% on the American Invitational Mathematics examination, which is, well, that's a very tough high school math competition.
That's serious capability.
It suggests these models are developing a capacity for multi-step abstract problem solving that could really change things in science or complex data analysis. There's also an O1 Mini, which is faster, cheaper, but still optimized for coding and STEM tasks.
And how do they achieve that reasoning?
They're using reinforcement learning specifically to improve step-by-step reasoning and error correction. It marks a shift towards AI that genuinely seems to think or plan before responding, not just predict the next word.
Fascinating. An AI that thinks. Okay, moving on. We absolutely cannot talk LLMs without talking about Google. Pioneers from the start, even co-authoring that original Transformer paper.
Yes, Google has deep roots here. Their BERT model, back in 2018, was revolutionary for understanding context because it processed text bidirectionally, looking both forwards and backwards.
Right.
That deep contextual understanding made it excel at things like question answering, sentiment analysis. Then they came out with T5, the text-to-text transfer transformer.
P5, okay.
Its clever idea was to frame all NLP tasks as a text-to-text problem. Input text, output text. This made it incredibly versatile for translation, summarization, you name it. Google really innovates from the foundational architecture upwards, seems like.
And PaLM was their really big model before Gemini, right?
That's right. PaLM, the Pathways language model, was huge, 540 billion parameters, showed state-of-the-art performance, really good at complex reasoning. And then in December 2023, they unveiled Gemini.
Gemini. That definitely made waves. What's its main claim to fame?
Gemini is designed from the ground up to be truly multimodal. Not just text and images tacked on, but natively understanding and generating text, images, audio, video, and code.
Natively multimodal.
Okay. It comes in a family of models. Gemini Ultra, their most capable, Pro, Flash, focus on speed and efficiency, and Nano for on-device tasks. The latest versions, like Gemini 1.5 Pro, offer their best general performance and boast a massive context window, 1 million tokens.
1 million tokens. We talked about context earlier, but remind us what that means in practical terms.
Yeah, it's staggering. 1 million tokens is roughly like 30 hours of audio, maybe 1,000 pages of text, or 60,000 lines of code, all held in its working memory at once.
Wow. So what's that good for?
Amazing for analyzing massive documents, summarizing really long meetings or videos, debugging huge code bases, anything where understanding a vast amount of prior context is key.
Right.
And as I said, Gemini 1.5 Flash is the speed-optimized version. Overall, Gemini excels in reasoning, pulling insights from data, explaining complex things like math and physics proofs, and it's considered a top-tier model for coding.
And they have open models, too.
Yes, the Gemma models. These are lightweight, open models built using the same core tech as Gemini. They offer great performance for their size, can even run on a developer's laptop, and Google emphasizes they're built with safety and reliability in mind.
Strong showing from Google. Okay, let's pivot to Meta AI. They've taken a somewhat different path, really focusing on open source contributions.
That's right. Meta AI has been a major proponent of the open source approach in the LLM space.
Yeah.
Their Llama series large language model, Meta AI, is a great example.
Comma, yeah.
These models range from 7 billion up to 65 billion parameters, and critically, they're trained on publicly available datasets. What was really notable was that their Llama 13B model was shown to outperform GPT-3 on several benchmarks without using proprietary data.
That's a big statement, right? Powerful AI doesn't have to be closed off.
Exactly. It emphasized that high performance was achievable openly, which is huge for researchers and smaller developers who want more control and transparency. Meta seems really committed to fostering a more democratized AI ecosystem.
So it's about making powerful AI more accessible, and they have a newer version, Llama 3.
They do. Llama 3 is the latest, and it shows some significant advancements, a much larger context window, 128,000 tokens, models going up to 405 billion parameters, trained on an absolutely massive 15 trillion tokens of data.
15 trillion.
Yeah, and it supports up to 30 languages, showing improved performance in language understanding, programming, math, logic. And for the coders, they also have Code Llama, specifically tuned for understanding, generating, and debugging code across lots of different languages.
Very useful niche. Okay, next up, Anthropic. Their big focus seems to be on safety and aligning AI with human values. What does that actually mean for their models like Claude?
Anthropic definitely positions itself with a strong ethical compass. Their main model is Claude, named after the information theory pioneer Claude Shannon.
Claude Shannon, cool.
Yeah, and the emphasis with Claude is on ethical AI deployment. They work hard to minimize harmful or biased outputs while still aiming for high performance on language tasks. Their latest are the Claude 3 models, introduced in 2024.
Okay, Claude 3. What can they do?
There's a family: Haiku, the fastest, most compact; Sonnet, a balance of speed and capability; and Opus, their most powerful, which they claim outperforms other top LLMs on many common benchmarks. They can handle open-ended conversation, collaborate on ideas, do coding tasks, work with text, and even process and analyze visual inputs like charts and photos.
So multimodal too, and they have a unique approach to safety, right? This constitutional AI thing. What is that?
Yes, constitutional AI is a core feature. It's basically a two-phase process. They use AI feedback, guided by a constitution or set of principles, to train the AI to be helpful, honest, and harmless. It involves both supervised learning and reinforcement learning phases to control the AI's behavior more precisely and reduce risks. It's fundamental to their design philosophy, building trustworthy systems from the start.
Interesting. A constitution for AI. All right, let's talk about Mistral AI. Based in Paris, quickly gaining prominence, often seen as a European rival to OpenAI, their focus seems to be on efficiency and speed.
Mistral AI has definitely carved out a strong identity. They emphasize smaller, yet impressively powerful models. And importantly, some of their key models are open weight, meaning fewer restrictions, and they can often be run locally, which gives users more control.
Okay.
Their Mistral Large model is designed for complex tasks, but still maintains rapid processing speeds, with a 32,000 token context window. It's known for generating coherent text and performs well on benchmarks, especially in programming and math.
And I've heard a lot about Mistral 7B, which seems to kind of punch above its weight class. How do they manage that efficiency?
It absolutely does. Mistral 7B, despite having only 7.3 billion parameters, outperforms much larger models like Llama 2 13B on many benchmarks. They achieve this through clever architectural tricks.
Like,
Things like grouped query attention, GQA, which speeds up the inference process, and sliding window attention, SWA, which lets it handle long sequences of text efficiently without the computational cost exploding. So you get great performance for less compute. It's also multilingual: English, French, Spanish, German, Italian open source, and easily fine-tunable.
really pushing the boundaries of efficiency.
They really are. Then they introduced Mixtral 8x7B. This uses a different architecture called Sparse Mixture of Experts, or SMOE.
Mixture of experts.
Yeah, basically it has multiple expert subnetworks, and for any given input, it only activates the most relevant couple of experts. This makes it incredibly efficient. Mixtral 8x7B is an open-weight model that outperforms Llama 270B on most tests, while being 6 times faster to run.
6 times faster.
Yeah. It's competitive with GPT 3.5, has a 32K token context, multilingual, great at code generation. It has 46.7 billion parameters in total, but only uses about 12.9 billion for any single token prediction, hence the speed and cost efficiency.
Clever design.
Very. They also have a bigger version, Mixtral 8x22B, with a 64K context window. It uses up to 141 billion parameters total, but only about 39 billion during inference, leading to better throughput if you have enough memory. And beside these open models, Mistral also offers proprietary ones, Mistral Small, Medium, and Large, through their platform, offering different trade-offs in speed, quality, and cost for various business applications.
Wow, a lot of innovation coming out of Mistral. What about Cohere? What's their particular angle in this crowded space?
Cohere's focus is largely on enterprise AI, creating technologies that augment human intelligence, especially in business contexts. Their command models are well regarded for understanding and executing instructions effectively.
Okay.
They introduced the Command R model, which specifically enhances capabilities using retrieval augmented generation, or RAG.
RAG, right, pulling in external data.
Exactly. It allows the model to integrate information from external databases, like a company's internal knowledge base, to provide much more accurate, up-to-date, and contextually relevant responses. Very important for enterprise use cases. And their Command R Plus model offers further enhancements for performance and accuracy in really demanding environments.
Connecting AI to real-time specific data makes sense for business. And of course, we have to mention the cloud giants, specifically AWS, Amazon Web Services.
Absolutely. AWS, being a leader in cloud computing, offers access to various models, including their own, through their Amazon Bedrock service. Their latest generation is the AWS Nova series.
Nova, okay.
These are high-performance LLMs designed for enterprise-scale applications, optimized for efficiency, faster inference, lower latency, and built with deep contextual awareness, making them good for in-depth analysis and conversational AI. They also have the Titan model family, including Titan Text for generation and Titan Image for visual content. A huge advantage for AWS is the seamless integration with their whole ecosystem: storage, databases, security tools, which is very appealing for businesses already invested in AWS.
Makes sense. Leverage the ecosystem. And finally, let's touch on DeepSeek, an emerging player from China.
Yes, DeepSeek is gaining recognition. They're an AI research organization from China producing high-performance LLMs that emphasize efficiency, multilingual capabilities, and strong reasoning. Their DeepSeek LLMs aim to compete with the state-of-the-art in language understanding, generation, and coding.
And coding seems to be a focus.
They have a specific DeepSeek coder model, optimized for programming tasks, generation, completion, debugging across multiple languages. A key part of DeepSeek's strategy seems to be cost-effective deployment, focusing on optimized inference speeds and lightweight model architectures.
That's a truly impressive lineup of heavy hitters.
Yeah.
Each one seems to have carved out its own niche, its own strength, its own strategic focus. Wow, now that we've met the players, let's really dive deep. How do they actually stack up against each other?
Right, this is where it gets really practical, doesn't it? Understanding the different models is one thing, but knowing how they actually perform on specific tasks in real-world scenarios.
Ah.
That's crucial for you, our listener, to figure out which tool might be right for you.
Okay, let's get into the nitty-gritty. When we talk about performance, what are we actually measuring? It's not just about who sounds the most human, right? What are the key metrics people use?
Exactly. There are several standard metrics used in the field. One common one is perplexity. It basically measures how well a model predicts the next word in a sequence. A lower perplexity score is better. It means the model is less surprised or confused by the text it's generating.
Lower is better. Got it.
Then there's straightforward accuracy. This just measures how often the model's predictions are correct. Really important for tasks like question answering or classifying text.
Makes sense.
And another important one is the F1 score. This one's a bit more nuanced. It combines two other measures: precision, how many of the results it returned were actually relevant, and recall, how many of the relevant results that exist did it actually find. A high F1 score means the model is good at being both precise and comprehensive.
Okay, so it's finding the right stuff and not missing too much. And even with all these numbers, I bet human judgment still plays a big role.
Oh, absolutely critical. Human evaluation remains vital. You need people to actually read the outputs or assess qualities like fluency, coherence, relevance, helpfulness. Does it sound natural? Is it actually answering the question usefully? Sometimes a model can score well numerically but produce text that just feels off or unhelpful to a human.
Right, the numbers don't tell the whole story. So
Yeah.
with those metrics in mind, what are the leaderboards saying right now? Who's generally considered top tier in different areas based on the latest benchmarks we have?
Okay, looking at some recent benchmark results. For pure reasoning, especially on tough benchmarks like GPQA Diamond, which tests graduate-level questions, Gemini 2.5 Pro seems to be leading the pack currently, scoring around 86.4%.
Yeah.
Grok 3 Beta from AXAI and OpenAI's O3 model are close behind. in the mid-80s as well. This shows a strong capability for complex logical thought among the top contenders.
So really pushing the boundaries on complex thinking. What about math?
For high school math, using benchmarks like the AMY competition problems, it's incredibly close. OpenAI's O4 Mini, Grok 3 Beta, and Gemini 2.5 Pro are all scoring in the low 90s percentile. It's practically neck and neck.
Wow.
What's fascinating here is how good these models are getting at step-by-step, precise problem solving. It really hints at a future where AI could be a genuine collaborator in complex scientific or engineering work.
It sounds like a really tight race at the top for these intellectual tasks. Super exciting.
It truly is. Now, for agentic coding, tested on benchmarks like SW Bench, which measures how well they can act like an autonomous coding assistant to resolve real GitHub issues, Claude 4 Sonnet and Opus are currently leading there, both scoring around 72–73%. That's a huge leap in AI tackling practical, real-world coding problems.
So Claude is strong on the coding agent side. What about using tools?
Right, their ability to use external tools effectively, measured by benchmarks like BFCL. Meta's Llama 3.1 405B model shows very strong performance, scoring over 80%. Llama 3.3 70B and GPT-4o are also quite capable there in the 70s. This is crucial for making AI useful in complex workflows.
And adaptive reasoning, handling new situations.
For adaptive reasoning, using benchmarks like GraiND, Gemini 2.5 Pro again shows a lead, scoring around 82%, with Claude 4 Sonnet also performing well at 75%. This tests how well they can adjust their thinking when faced with novel problems.
And is there an overall best, according to these benchmarks, like that humanities last exam one? Sounds comprehensive.
Yeah, the best overall Humanities Last Exam benchmark tries to measure broad general intelligence across many domains. Gemini 2.5 Pro and OpenAI's O3 model are currently leading there, both scoring around 20–21%. It's tough, but they're at the top. For the widely used multitask language understanding MLU benchmark, GPT-4 has historically held a lead, scoring close to 89%, though Gemini is very competitive, and Mistral Large is also strong, around 84%. For specific reasoning tasks, like GPQA, other analyses show Claude performing very well, sometimes even ahead of GPT-4 in certain reasoning areas. And interestingly, for multilingual capabilities on MGSM benchmark, both Claude and Llama score very highly, around 91–92%, showing they're really effective across multiple languages.
It's crystal clear from this that different models really do excel in different areas. There's no single winner across the board. It totally reinforces that idea that the best model depends on what you need it for.
Precisely.
So, okay, what does this all mean for you, the listener, trying to make sense of it? Let's peel back the curtain a bit more on the technical stuff that defines these models. What's going on under the hood?
Right. So the foundational architecture for most of these leaders is still the transformer model we discussed. But, as we hinted, each company puts its own spin on it, leading to different strengths. OpenAI's GPT-4, for instance, is a transformer-based autoregressive model. That means it predicts the next word based on the sequence it's already generated. This design makes it really good at creating coherent, flowing text that often feels incredibly human-like.
And Google Gemini's architecture, what makes it stand out?
Google Gemini, also transformer-based, but its key architectural difference is being natively multimodal. It's designed from the ground up to process text, images, audio, etc., all within the same core structure. This allows for a deeper fusion of information across modalities compared to models where multimodality might be more bolted on.
So it's not just seeing an image and describing it, it's truly integrating that visual info with the text understanding. That sounds powerful.
Exactly. For Meta AI's Llama, again, transformer-based, but with a real focus on efficiency and performance for its size. And crucially, its open-source nature means the architecture itself is transparent, allowing the community to study, modify, and build upon it.
Right, that openness is key.
Anthropic's Claude uses the transformer, but builds in its safety mechanisms, like constitutional AI, at a fundamental architectural level. Safety isn't an afterthought, it's part of the blueprint. And Mistral, as we discussed, stands out with its architectural innovations like grouped query attention, GQA, and sliding window attention, SWA, which are specifically designed for efficiency and speed, especially when dealing with long sequences of text.
Okay, that covers architecture. Now let's talk about parameter count, the scale of intelligence. We hear these huge numbers, billions, even trillions. Is bigger always better? What does this really mean for a user?
It's a good question. Generally, yes. A higher parameter count often correlates with a more complex and nuanced understanding of language. More parameters usually mean the model can capture more subtle patterns, leading to better performance in generating human-like text and tackling intricate tasks.
But there's a trade-off, right?
Oh, definitely. The big trade-off is computational resources.
Hmm.
More parameters mean significantly more computing power is needed for both training the model initially, which is incredibly expensive, and for running it day-to-day inference. This directly impacts the cost and speed for the end user.
So it's a balance. Give us some context on the numbers again for the big players.
Sure. OpenAI's GPT-4 is estimated to have over 175 billion parameters, maybe significantly more in some configurations. Google Gemini varies by version, but their largest, Gemini Ultra, is speculated to be well over a trillion parameters, truly massive.
Ah.
Meta AI's Llama 3 largest model is 405 billion parameters. And Mistral, even with their efficiency focus, has models like Mixtral 8 by 22B, technically having 141 billion parameters total, though they only use a fraction at inference time. These are genuinely gigantic digital brains.
Mind-boggling scale. Okay, what about the fuel for these brains, the training data? Where do they get all this knowledge, and how much does the type of data influence what they're good at?
The training data is absolutely crucial. You are what you eat, right? OpenAI's GPT-4 is trained on an incredibly diverse mix of internet content, websites, books, articles, giving it that very broad general knowledge from pop culture to scientific concepts.
Okay.
Google Gemini, as we said, uses multimodal data sets, text and images, maybe video and audio too. This enhances its ability to understand context across different formats, making it strong on tasks involving visual input.
Right.
Meta AI's Llama models deliberately focus on using publicly available data. This promotes transparency and accessibility, allowing researchers to better understand the training influences and making it easier for the community to replicate or build upon their work.
Good for openness.
Anthropic's Claude uses training data that's carefully curated and filtered to minimize bias and harmful content, aligning with their safety-first philosophy. And Mistral trains on multilingual data sets to ensure good performance across languages, and they seem to have a strong focus on including coding data, which likely contributes to their strength in programming tasks.
So the data really shapes the model's personality and skills in a way, which leads nicely into their unique functionalities. What makes each one special? What are their individual superpowers beyond just the raw processing power?
Yeah, each one definitely has its own flavor or standout features. OpenAI's GPT-4 is just renowned for its creative writing abilities. It can adopt different styles, generate really engaging narratives. It's incredibly versatile for producing human-like text across almost any domain. That's often seen as its superpower.
Okay, the creative powerhouse.
For Google Gemini, it's undeniably the native multimodality, seamlessly integrating text with images, audio, video. Makes it ideal for applications needing rich context analysis, like understanding complex reports with charts or analyzing video content. It's also noted for handling very long documents or complex queries well.
And for Meta AI, what's its special sauce?
Meta AI's Llama and its successors, being open source, offer incredible flexibility as their unique advantage. Developers can take the base model and fine-tune it deeply for their specific needs, whether it's a particular industry or task. That level of customization is powerful.
Control and customization. Got it.
Anthropic's Claude's unique function is its built-in focus on ethical AI and safety. The constitutional AI framework actively works to reduce harmful outputs and ensure the model behaves in ways aligned with human values, making it a strong choice for sensitive applications where trust is paramount.
The responsible AI.
You could say that. And Mistral really shines with its efficiency and speed thanks to those advanced attention mechanisms like GQA and SWA. They allow it to capture complex data patterns effectively while being fast. Mistral models also often support enhanced function calling, which means they're good at interacting with external APIs or tools, making them very useful for building complex applications and workflows.
Okay, this is great for understanding the technical side, but benchmarks and specs are one thing. What does this actually feel like to use? Let's get into a real-world showdown, drawing on some hands-on comparisons. How do these LLMs perform when you're actually trying to get stuff done?
Exactly. This is where the rubber meets the road. Theory is one thing, practice is another. But before we jump into specific use cases, let's quickly revisit that crucial concept, the context window.
Right, the model's memory.
Yeah, basically how much information it can keep track of and process at once. A larger context window means it can understand longer conversations, analyze entire documents, or work with complex code bases without losing track. Just to give you that relatable guide again, 1 million tokens, which models like Gemini 1.5 Pro offer, is roughly 30 hours of audio, 1,000 pages of a book, or 60,000 lines of code.
1 million tokens. That's just incredible. Thinking about being able to feed an AI an entire novel and then discuss it. Wow. Okay, on to the showdown. Let's start with a really common use case, content creation, writing articles, emails, creative pieces.
Okay. Based on many comparisons, ChatGPT, especially GPT-4, consistently tends to deliver the most coherent and engaging responses for creative and structured writing. The text often flows naturally, the tone feels polished, and it often requires less editing than others. It's frequently cited as the go-to for long-form content or when you need that creative spark.
Okay. Chat GPT for polish. How about the others?
Google Gemini typically produces well-structured content with a solid, factual grounding. It's often very informative, but maybe sometimes lacks a bit of ChatGPT's creative flair or natural flow. It can feel a bit more formal, perhaps.
Right.
Meta AI, usually accessed through their apps, is often described as serviceable for basic needs, like short social media posts. But for more complex or sophisticated content, it tends to struggle with depth, producing shorter, more surface-level responses that likely need significant rewriting or enhancement.
Gotcha. So different levels of sophistication there. What about for the developers listening? How do these models stack up for coding assistance? Writing code, debugging?
This is a huge use case. Both ChatGPT and Google Gemini are generally considered strong coding companions. ChatGPT is often praised for its ability to explain complex programming concepts clearly and help debug tricky issues across a wide variety of languages.
Mm-hmm.
Google Gemini, however, holds a notable advantage when dealing with Google Cloud-specific queries, or APIs. Its explanations of Google's own ecosystem seem particularly impressive, likely due to deeper integration and training data.
Makes sense. Synergy there.
Exactly. Unfortunately, Meta AI generally lags considerably in coding assistance based on current comparisons. It might provide basic code snippets, but frequently misses nuances, doesn't follow best practices, or struggles with more complex programming logic.
Okay, so ChatGPT and Gemini lead for coding, with Gemini having an edge for Google stuff. How about just getting facts?
Right.
Straight up fact-based queries. Who's the most reliable and up to date?
For pure factual recall and up-to-date information, Google Gemini often shines the brightest. Leveraging its connection to Google Search, it consistently delivers accurate, current information, making it an excellent choice if you need specific facts, statistics, or information about recent events.
The power of search integration.
Definitely. ChatGPT, especially with its web browsing capability enabled in paid versions, performs admirably, often providing accurate info, but sometimes minor inaccuracies or slightly older information have been noted compared to Gemini's real-time search link.
Okay.
Meta AI, again, tends to struggle here. Comparisons often find it providing vague or outdated information, suggesting its underlying knowledge base might be more limited or less frequently updated for factual queries.
So for quick, reliable facts, Gemini seems like the safest bet. Interesting. What about just chatting, casual conversation? Who feels the most natural to just talk to?
This is where it gets interesting, because the results can be surprising. For just light, everyday chit-chat, Meta AI often gets praised for offering the most natural-feeling conversational experience. It can be responsive, friendly, almost like texting with a person, perfect for quick, informal interactions.
Really? Meta. Okay.
Yeah, but it tends to hit its limits quickly if the conversation gets more complex or requires deeper knowledge. ChatGPT usually strikes an excellent balance. It can maintain conversational warmth while also providing substantive responses, making it engaging across both casual chats and more complex discussions.
Right.
Google Gemini, while very informative, is sometimes described as feeling a bit more mechanical or formal in purely conversational contexts. The responses might be comprehensive, but lack that personal quality you might want in a casual chat.
Fascinating how the strengths shift depending on the task. Okay, image generation. This has exploded recently. Who's leading the visual charge?
Yeah, image generation is huge now. Here, ChatGPT, particularly when powered by OpenAI's DLE-3 model, is widely considered the leader among these integrated chatbots. It consistently produces strikingly realistic, creative, and often quite nuanced visuals from text prompts. And OpenAI's separate Sora model for video generation further cements their lead in multimedia creation.
DLE3 is impressive.
It really is. While Meta AI and Google Gemini do offer image generation features, comparisons generally find they don't quite match ChatGPT DL83's versatility, prompt adherence, or overall output quality yet. They're more basic, generally speaking.
Got it. What about deeper research capabilities? If I'm writing an article, a paper, and need reliable info, maybe even sources.
For research assistance, ChatGPT again often proves very valuable. Its ability to access and synthesize current information with web browsing is strong, and crucially, it often provides source links to support its claims, even on the free plan sometimes. which is a huge benefit for verification and further reading.
That citation piece is key for research.
Absolutely. Google Gemini, despite its search engine roots, surprisingly sometimes falls short on providing specific citations and comparisons. It might give accurate info, but offer only broad references rather than direct links to articles or sources, which can be frustrating for researchers.
Interesting shortcoming.
Meta AI generally performs averagely here, not really standing out for deep research support.
Okay. And finally, the need for speed. Speed and responsiveness. How quickly do you get your answers? This matters a lot for user experience.
It really does. Meta AI is often noted for delivering impressively fast responses. It feels very quick. However, this speed can sometimes seem to come at the expense of depth or thoughtfulness in the answers. It's a trade-off.
Quick, but maybe shallow sometimes?
Potentially, yeah. ChatGPT usually maintains an excellent balance between speed and thoroughness, especially with the optimized GPT-4 Turbo model. Responses are generally quick but still feel well considered. Google Gemini is also generally rapid for most queries, but comparisons sometimes note that it can occasionally lag or take longer when processing more intricate prompts, particularly those requiring complex reasoning or synthesis of specialized knowledge.
That's a fantastic side-by-side. It really drives home that best is totally subjective, right? It depends entirely on what you need it to do.
100%. There's no single silver bullet.
So let's tie this all together. The bottom line. Pros, cons, and crucially cost for each of these major players. Let's give people the quick takeaway for each.
Right. Let's summarize the key advantages and disadvantages so you can start thinking about which might be the best match for your needs.
Okay, kick us off with OpenAI GPT-4 and its variants.
Okay, OpenAI GPT-4, the pros. Its biggest strengths are high versatility, great for creative writing, coding help, building conversational agents. It generates truly human-like text, often setting the bar there. And it has a robust API, making it easy for developers to integrate into their own apps.
And the downsides.
The cons. It can be costly to operate, especially the most powerful versions, due to the high computational requirements. There's always the potential for generating misinformation, if not carefully prompted or fact-checked. And it can sometimes feel like a black box. It's hard to know exactly how it reached a conclusion. Plus, the free version has significant limitations, like outdated knowledge and usage caps, and sometimes it can be overly verbose, over-explaining simple things.
Okay, clear trade-offs. What about Google Gemini?
Google Gemini and its family. Pros? Its powerful native multimodal capabilities are a huge plus, handling text, images, audio, video seamlessly. It has strong reasoning skills, great for analytical tasks. It's designed for scalability and handling large datasets or long context really well. And the integration with Google Workspace tools is a big bonus for users in that ecosystem.
And the Gemini cons.
Cons. It's resource-intensive, needing substantial computing power, which can translate to cost. Data privacy is always a concern when dealing with Google, especially if handling sensitive data. Like all LLMs, there are bias risks. It can perpetuate biases present in its training data. And some of its best features, like the largest context window or advanced capabilities, might be locked behind paid Google One subscriptions. Performance can sometimes struggle with really complex multi-step requests, too.
Got it. Moving on to Meta AI Llama and its family, like Llama 3.
Meta AI Llama. The big pros. Its open-source accessibility is key. This allows for deep customization, community-driven improvements, and often makes it more cost-effective, especially for research or smaller teams. It delivers competitive performance across many tasks. It's generally free to use without paywalls, easily accessible within Meta apps like WhatsApp or Instagram, and has those fast, casual conversation skills we mentioned.
And the cons for Llama?
Cons. Being open source can mean less extensive commercial support compared to proprietary models from OpenAI or Google. Updates and improvements rely heavily on community contributions, which can be variable. There's still potential for biases in outputs, just like any LLM. Its responses often lack the depth or analytical rigor of top competitors. It can feel more like a helpful add-on than a full-fledged AI assistant sometimes. And users have noted limitations in sharing entire chat histories easily.
Okay, good overview. What about Anthropic Claude, the safety-focused one?
Anthropic Claude. Pros. Its strong focus on safety and ethics is its main differentiator, designed to minimize harmful outputs. It generally shows high alignment with user intent, trying to be genuinely helpful and harmless. They also make efforts towards transparency and explainability. This makes it a strong candidate for sensitive applications where trust and reliability are paramount.
Cons for Claude.
Cons. That very emphasis on safety might sometimes lead to slightly less creative or perhaps more cautious responses compared to models optimized purely for performance or engagement. Performance can be variable across the full spectrum of NLP tasks. It might excel in some areas but lag in others. And despite the focus on safety, it still requires significant computational resources to run effectively.
Right, safety doesn't necessarily mean simple. And Mistral AI.
Mistral AI Pros, known for efficiency and speed, punching above its weight, particularly excels in programming and mathematical tasks, offers strong multilingual support. Crucially, provides powerful open-weight options, like Mistral 7B Mistral models, that allow for local operation and give users greater control and customization via fine-tuning.
And the cons for Mistral.
Cons. For their proprietary models, small, medium, large, there are the usual trade-offs between speed, quality, and cost that users need to evaluate. And while the open-weight models offer great freedom, they generally require more technical expertise to deploy and manage effectively compared to simply using a Cloud Cat API. So there's a higher technical barrier to entry for the open options.
Okay, that covers the main players. Now let's talk dollars and cents and milliseconds. The cost comparison and speed latency, this is often a huge factor, right?
It absolutely is, especially for businesses or heavy users. When you look at the cost comparison, typically measured in US dollars per 1 million tokens processed, input tokens often cost less than output tokens. The range is just massive.
Oh, massive.
You've got incredibly affordable options at one end. Models like AWS Nova Micro, costing literally pennies per million tokens, like 0.04 cents for input, 0.14 cents for output. Open models run locally can be free aside from your hardware costs. Google's Gemma 327B is around 0.7, so for both input and output. Gemini 1.5 Flash is also very competitive, around 0.075 input, 0.3 output.
Okay, very cheap options exist. What about the high end?
At the other extreme, the absolute cutting-edge models can be significantly more expensive.
Mm.
For instance, some reports put experimental or next-gen models like a hypothetical GPT 4.5 at potentially $75 for input and $150 for output per million tokens. That's a huge investment. OpenAI's powerful O1 model is listed at $15 input, $60 output. So the cost can vary by orders of magnitude depending on the model's capability and provider.
Wow, quite the spread. You really pay for that peak performance. And for speed, who gives you those answers the fastest? Tokens per second, latency.
Yeah, speed is crucial for user experience. For fastest models measured in tokens per second, how quickly the text appears, some benchmarks show models like Llama 4 Scout, potentially from a newer generation, hitting an astonishing 2,600 tokens per second. Llama 3.37b is also incredibly fast at 2,500 tokens per second. These are just blazing fast, text appearing almost instantly.
Like it's reading your mind?
Almost. And then there's lowest latency, which is the time it takes for the first token or word to appear after you hit send. This affects how responsive the model feels initially. Here, models like AWS Nova Micro are incredibly quick, around 0.3 seconds. Llama 3.18b, Llama 4 Scout, Gemini 2.0 Flash are all in that 0.3 to 0.34 second range. These are the blink and you'll miss it models. You hit enter, and the response starts immediately.
Fantastic. This pricing and speed data really underscores that it's not just about picking the smartest model. It's about finding the right balance of capability, cost, and speed for your specific needs and budget.
Precisely. It's a complex equation with many variables.
Okay, so we've thoroughly dissected the current landscape. Now let's put on our future-gazing hats. What does the road ahead look like? Where are LLMs heading? If we connect this to the bigger picture, it feels like we're just getting started, right?
Oh, absolutely. The pace of innovation is relentless. And if we look at the trends, we can see several key directions emerging that will likely shape the future of LLMs. It's incredibly exciting.
What's the first big trend you see really impacting how we use these tools?
One of the most significant trends is definitely specialization and fine-tuning. While the big general-purpose models are impressive, we're seeing a strong push towards LLMs becoming experts in specific industries or domains.
Okay, like niche experts.
Exactly. Imagine models fine-tuned on massive amounts of data, specifically from healthcare or finance or law. These models will deeply understand the jargon, the specific workflows, the regulations within that field. They'll be able to perform highly relevant tasks with much greater accuracy and nuance than a general model ever could. So less of a jack of all trades, more like having an AI specialist for specific needs.
An AI lawyer, an AI financial analyst, tailored tools. That sounds incredibly powerful for professionals. What else is coming down the pike, maybe for how we interact with them, especially if we're not coders?
Well, related to coding, but with huge implications for everyone, is enhanced code generation and natural language programming interfaces. LLMs are already great coding assistants, but they're getting better constantly. More complex code, better debugging.
Right.
But the truly revolutionary part is the rise of natural language programming. The idea is that you will be able to simply describe what you want an application or piece of software to do in plain English, and the LLM will translate that directly into working code.
Whoa. So literally just talking your ideas into existence.
Pretty much. This could effectively democratize programming, making software creation accessible to a vastly broader audience, even those with zero traditional coding skills. It could unleash a wave of innovation.
That is democratizing. Amazing potential. What other major advancements should we expect?
We're definitely going to see a continued expansion of multimodal learning. We talked about Gemini and GPT-4o, but future LLMs will integrate text, images, audio, and video even more deeply and seamlessly.
How so?
Imagine models that can truly understand the entirety of a complex information source, like watching a documentary and comprehending the visuals, the spoken narration, the background music, the on-screen text all together, and then being able to answer nuanced questions or generate summaries that incorporate all those elements. This will unlock incredible applications in content creation, personalized education, interactive media. It goes way beyond just text.
Truly comprehensive understanding. That brings up trust, though. These models can sometimes feel like inscrutable black boxes. Is anything changing there?
That's a critical point. And yes, there's a growing focus on explainable AI or XAI. As these models become more powerful and integrated into critical systems, transparency is essential.
Right.
So future LLMs will increasingly be designed to articulate how they arrived at a particular conclusion or recommendation. They'll need to show their work, essentially. This is vital for building trust with you, the user, and for developers to debug issues, ensure fairness, and generally make sure the AI is being used reliably and responsibly.
Showing their work. That would be a massive step forward for trust and accountability. What about how they might work with us, or even with each other?
We're likely heading towards collaborative programming and teamwork. Imagine LLMs not just as tools, but as genuine partners for teams of developers. They could help streamline communication, facilitate code reviews, manage project workflows, acting like an AI team member to boost productivity and foster innovation.
An AI teammate. Cool.
And another key area is improving reliability through real-time fact-checking. A major limitation now is that models often rely on the knowledge frozen during their training. Future models will likely incorporate much tighter integration with live data sources and fact-checking mechanisms.
So no more my knowledge cutoff is answers.
Hopefully. The goal is for them to provide genuinely up-to-date, verified information, especially for current events or rapidly changing topics, which would significantly enhance their reliability.
That would be incredibly useful. Any other big trends on the horizon?
Two more quick ones. First, synthetic training data. Research is actively exploring using LLMs to generate their own high-quality training data. This could allow for continuous self-improvement without constant, massive human data collection efforts, potentially accelerating progress even further.
AI teaching itself. Wild.
Kind of. And finally, we're seeing more development of sparse expertise models, like Mistral's Mixtral. The idea is to build models that are still huge overall, but only activate the relevant expert parts of their network for any given task. This makes them much more efficient to run, reducing computational costs and energy consumption while maintaining high performance. Efficiency is going to be increasingly important as these models scale.
That's a truly exciting glimpse into the future. Specialization, natural language coding, deeper multimodality, explainability, collaboration, real-time info, self-improvement, efficiency. It really sounds like LLMs are poised to become even more deeply woven into our lives, but hopefully in more understandable, trustworthy, and targeted ways. So what a journey we've been on today. It feels like we've covered a huge amount of ground. We started by really unpacking what large language models actually are, diving into that core transformer technology, the self-attention mechanisms, and their incredible diverse capabilities.
From generating text to analyzing sentiment. Then we took that grand tour of the heavy hitters, didn't we? Meeting the powerhouses like OpenAI, Google, Meta AI, Anthropic, Mistral, Cohere, AWS, and DeepSeek. We highlighted their flagship models and their unique approaches and contributions to this rapidly evolving field.
Yeah, and we didn't just stop at introductions. We dove deep into how they actually stack up against each other. We looked at those crucial performance benchmarks, unpacked the technical differences, under-the-hood architecture, parameter counts, the all-important training data, those unique functionalities.
And we even staged that real-world showdown, comparing how they perform head-to-head on common tasks like content creation, coding help, factual queries, even just having a casual chat. Plus, we broke down the bottom line, the pros, the cons, and importantly, the costs and speed factors for each major player, giving you that comprehensive overview.
And finally, we looked ahead, exploring those fascinating future trends from deep specialization and the dream of natural language programming to richer multimodal understanding and the crucial push for explainable AI. It's clear these are incredibly powerful, rapidly evolving tools, each with its own distinct strengths and ideal applications.
Which really brings us to a final, maybe provocative thought for you, our listener, to mull over. The question isn't really about finding which AI is objectively universally best, because as we've seen, there probably isn't one.
Right.
The real question is which one, or maybe which combination, aligns most effectively with your unique workflow, your professional demands, your creative goals, and even your personal preferences.
Exactly. The most effective approach might not be choosing just one single LLM and sticking with it. Maybe it's about becoming fluent in several, strategically leveraging each for what it does best.
Yeah, imagine using ChatGPT for its amazing creative writing prowess, then switching to Gemini for its deep research capabilities and seamless Google integrations. Maybe using Meta AI for quick, informal social media posts or brainstorming. It's about building your own AI toolkit.
Right. And the distinctions between these AI giants, they'll likely continue to both sharpen as they specialize and maybe blur in some areas as they all strive to improve across the board. That competition is ultimately great news for users.
Absolutely. Because the real winner in this incredible race, ultimately, is you. As these AI giants push each other fiercely to deliver increasingly sophisticated, helpful, and accessible experiences, they're opening up entirely new possibilities for everyone's productivity, creativity, and daily interactions.
So we encourage you. Take what you've learned today, maybe experiment a little, and explore how these cutting-edge models could enhance what you do. The future of AI is here, it's evolving incredibly fast, and it's increasingly being built to serve you. Thanks for joining us on the Deep Dive.